Go to properties and then go over this one. Yeah, I think so. Now it might be okay. Is my voice clear? Can I get a yes? Then I'll wait for 2 to 3 minutes and then we can probably begin with the entire agenda of the session. And we're going to solve a bunch of questions as well. Yeah, it's okay. It's okay then. I'll pop out this thing. Done. Okay, then let's begin. So I think so. I should wait for 2 to 3 minutes. Then we can begin. Also, today in this session, it's going to be crisp and short, and we are going to have fun in this session. You can also post in your doubts, and I'll try my best to answer them according to my knowledge. And again, in this video, we are looking at how we can go about cracking TCS NQT. It's a very important exam if you want to get into any one of the roles available at the company TCS. Again, the TCS NQT exam, if you opt for the programming one as well, then I think so you will probably get a bunch of MCQs and then programming questions, basically coding questions, right? And again, before I go forward, I want to introduce myself. So I am a software engineer, currently working at Texas Instruments. And yeah, that's a little about me. I also did my computer science and engineering. So I think so that should be it from my end. Yeah, I think so I should wait for a minute just before starting. We'll look at a few of the things, how we can go about what should be your mindset, what should be your preparation, and then so on. And I believe so most of you guys are smart enough, and most of you guys will be able to solve the MCQs part. And again, MCQs should be not taken lightly. They also account for your marks. So definitely you have to practice a lot of them. So pick a topic, and then let's say it could be speed, time, and distance, right? I might have messed up the order, but it's speed, time, and distance. So pick the topic and then solve, let's say 20 to 25 questions, and then so on, right? So I think so that should be it. And I'm also going to talk about coding aspect as well. Yeah, I'm also going to talk about the coding aspect as well. So how you will be able to approach the problem. And just for it, and just for the demonstration purpose, I'll go over 2 of these questions. Okay, let's begin. I think so it's quite enough. It's more than 2 minutes. Okay, so TCS NQT. So let's talk about what your mindset should be. So for example, there's a bunch of topics. Let's say this is topic 1, topic 2, topic 3, topic 4, and then so on till topic N, right? There's a few of the topics, and you're like, okay, I want to study all of them and ace the exam, right? And it's completely fine, right? But again, for that, you need time for preparation and consistency, and you have to, again, as I mentioned, time management, right? So in this case, let's say you have very small amount of time left, right? And in the small amount of time, let's say you are saying that, okay, I'll be able to cover only these first four topics. And let's say there were more 6 topics remaining, right? There were more 6 topics remaining, but you were only able to cover the very first 4 topics. Now, let's say you are going to give your exam, right? You're going to give your exam. While giving your exam, don't think about all of these 6 topics. Don't have this mindset that, okay, I have not yet completed this, or that I have missed out on that, so I'll be not able to pass the exam, or I'll be not able to do good in my exams, right? No, don't concentrate on that. Focus on your strengths, right? Focus on your strengths. In this case, your strength is your topic 1, topic 2, topic 3. It could be speed, time, distance. It could be anything. It could be coding problems. It could be a subtopic in coding problems, binary search, linear search. It could be sorting, quick sort, merge sort, and then so on, right? Or applications of them. Topic 3 could be as simple as, let's say, you can take mixtures and allocations, right? There's a very common problem around mixtures and allocations. Topic 4 could be something like something related to MCQs, right? So again, just focus on your strengths, right? Focus on your strengths. Again, if you have time left for your exams, then you can definitely go about preparing the rest of the topics as well. But again, if you don't have time, please focus on your strengths and go about giving the exams. What if in the exams, let's say by chance you get a lot of questions from this area, right? Then definitely you have to kind of go ahead with it, right? So that's why I'll say that, okay, the very first one is focus on your strengths. Second one is time management. Yeah, indeed, second one is going to be time management. Now, why am I saying time management? The reason being, definitely you have this, right now, you might be having that, okay, the questions are given to me, and then I have ample amount of time left for me, ample amount of time left with me to solve any one of these questions. So previously in TCS, I'll tell you one thing. Previously in TCS, if you look at the MCQs, right? If you look at the MCQs previously in TCS, what used to happen was that, let's say you have question 1, question 2, question 3, question 4, and then so on, right? What used to happen was, for each particular question, you had a time limit. Yeah, for each particular question, you had a time limit. Let's say the time limit is 1 minute, or it could be 1 minute, 30 seconds, and then so on, right? So there was a particular time limit allocated to a particular question. So for example, I'm attending question number 2, and it's a mixture and allegations problem, and the time assigned to it is 1 minute 30 seconds. Assume that time limit is 1 minute 30 seconds. So after 1 minute 30 seconds crosses, you automatically get redirected to question 3, right? Or you have to manually go to question 3 because the time allocated for that question is over, right? But right now, TCS have I think so, they have kind of changed this pattern that, okay, if you have question 1, question 2, question 3, question 4, and then so on, then they are saying that, okay, I'll give you the time. Let's say I'll give you 30 minutes, no problem. I'll give you whatever the time allocated is, 30 minutes, but there will be no cap, no time limit cap on each particular question. So definitely what you can think is that, oh, okay, so there's no there's no time limit on each question. So maybe if question 1 I have solved, question 2 I'm not able to solve, I'll give maybe 5 minutes to it and take my own comfort time and try to solve it, right? No, don't do that. That's why I'm saying time management, right? Earlier, when it used to be something like, okay, on one question, you have a time limit. So you had this thing in your back of the mind that, okay, I have to complete it within the given time frame. But right now I know for a fact that, okay, there's no time limit on each question. So as a general human nature, we might have this tendency that, okay, I'll give my own sweet time to any one of my favorite questions, right? No, don't do that. Again, set a time limit at the back of your mind. Then see that, okay, if I cross that time limit, I'll go to the next question, despite not solving that. Also, there's one more thing you have to take care of. Please take care of this thing. Let's say this question 1, question 2, question 3. Now you solved question 1. When you go to question 2, right, you cannot go back to question 1. Yes, you cannot go back to your previous question, despite you have solved it or not. So for example, I might be not knowing this, right? So let's say I'm like at question 2, and I'm like, okay, I'll do this question 2 later on. I have flagged this question, I'll do this question 2 later on. So what I'll do is, when I go to the next question, question 3, I solve this. Then I see that, okay, there's no back button, right? I mean, you cannot access the questions which are already skipped, right? Skipped in the sense you might have solved them or you might have not solved them, right? That's it. These are the few of the things which you have to take care of. And again, don't do silly calculation mistakes. For example, in mixture allegations problem, or it could be in speed, time, and distance. So we all know for a fact that if the problem is quite easy, or you also know the workers problem, right? So if these many men and women do the work in this days, how many people will be required to do that same work in this many days, right? So again, in those questions, we are quite smart enough. We know how the approach is, but sometimes we kind of do some mathematical mistakes, right? For example, I could be doing 4 into 3 by 2, and I know that this answer would be 6. By mistake, I wrote 8, right? Back of the mind, by mistake. No, please don't do that. If you know the problem, then please spend, let's say, a considerable amount of few more seconds just to get the mathematical corrections, right? I mean, the mathematical, mathematical corrections, right? That's what I'm trying to say. Okay, with respect to MCQs, this is over. Let's shift on to the coding aspect, right? So with respect to coding, again, I'll highly suggest you to go over the classic algorithms, such as sorting algorithms. In sorting algorithms, you can have simply quick sort algorithm. Then you can have something like merge sort algorithm. And then you can simply go for something like bubble sort algorithm, and then so on, right? But again, when I'm saying quick sort and merge sort algorithms, what I'm trying to say is that there could be a question revolving around the application of them, right? So when I say quick sort, they won't really ask you to do a quick sort. When I say merge sort, they won't really ask you to do a merge sort. When it's quick sort, they might give you a question that, okay, find the kth smallest element, right, in the array. Or when it's merge sort, they might give you the question that, okay, count, I can even say something like count of inversions. Yes, you can definitely look on to these questions. So this question, count of inversions, has the application of merge sort. Kth smallest element or kth largest element has the application of quick sort, and then so on, right? So I'm not saying that, okay, go ahead and mug up quick sort and merge sort. Try to understand their application so that you can apply to not only these questions, but any one of these questions you get in the worst case in the exam, right? Okay. Apart from sorting algorithms, you have to definitely go over searching algorithms, because these are the very few most common algorithms which can be applied to a problem, depending on the problem. Again, I'm not saying you have to apply it. So in searching, you definitely have the very easiest one, which is linear search, which I am thinking that everyone will be able to do. And then we have indeed the binary search algorithm. So again, go over both of them, go over a bunch of problems for both of them. Then you will be able to, then you will be having that confidence in the exam to get that problem done, right? I'll give 1 minute right now just to see if there's anything in the chat. Okay, we don't have anything right now. So let's quickly, is this going to be refreshed or give me the live chat? No, we don't have anything. That's great. Okay, so what we are going to do is we are going to go over some of these problems. Yeah, we are going to go over some of these problems. Let's see. The very first one is the question one, right? So given an array, let's say 7, 4, 8, 6, 11, 10, and 15, count the number of indexes which are special. And again, it's said that, okay, a special index is the one which has a value greater than all the prior values. Great. So we are given this array, right? So in this case, it's 7, 4, 8, 6, 11, 10, 15. That's saying that, okay, I need to indeed count the number of indices which are special, right? So the special index definition is given here in this note section. So it's saying that a special index is the one which has a value greater than all the prior values. So in this case, if you pick any index, right, let's say if you pick 0, 1, 2, if you pick the second index, right, what is the value at the second index? It's 8. So I can say that the special index has a value, which is in this case 8, greater than all the prior values. What do you mean by the term prior? So the term prior means that, okay, all the previous ones, right, prior to this value 8, prior to this index 8. So in this case, what are all the values before 8? In this case, I see the values before 8 are indeed 7 and 4. So is 8 greater than all the values before it? I can say yes, it is. So is this one of the answers? Yes, it is one of the answers. Can you tell me if try to understand this, You don't even need to tell me. Try to understand. If you are at 4, what are all the prior values? All the prior values are 7 only, right? Is 4 greater than all the prior values? No, it's not. In this case, can this count as a special index? No, it cannot. Great. What about 7? Can 7 be a special index? Yes, it is indeed a special index just because it has no prior values. So I know for a fact, since it has no prior values, hence by default, 7 or any value which is the very first element in the array is going to be a special index. That's it. Okay, what about 6? The prior values are 8, 4, and 7. Is 6 greater than all of them? No. 11. Is 11 greater than all of the prior values? Indeed. So I think so we have counted 3 special indexes, 7, 8, and then 11, right? So that's 3. What about 10? Is 10 greater than all of them? No. 11 is greater than 10, right? So that's the problem. Okay, what about 15? Is 15 greater than all of these prior values? Indeed it is. So what's the answer for this? What's the answer for this? The answer to this problem would be, or I can simply say the count answer to this problem would be, that's 1, 2, 3, 4. I think so that should be 4. Now, how we can go about computing this? The very first thing you should think of while getting the problem is that, okay, I should not rush into solving the problem in a very optimal way, right? I should not definitely rush into solving the problem in an optimal way. The sole reason being I might get misguided there, right? So first let's try the brute force method, right? First, let's try the brute force method. What could be the brute force method? Let's see. So 7, 4, 8, 6, 11, 10, 15. So I'll quickly go over here and write these here. So 7, 4, 8, then we have 6, 11, 10, and 15, right? I'll quickly see if my audio is kind of working. Yeah, that's fine. So in this case, let's say the brute force method, what it could be. And we are also going to take a look at the time complexity of that and the space complexity of that, of the brute force method, right? So let's say the brute force will be, let's say you are at a particular index. Let's say this is 0th index, 1st, 2nd, 3rd, 4th, 5th, and 6th. And what I'll do is I'll quickly change the color. Yes. So let's say you are at the 0th index. what you'll do is you will run a for loop. Yes, you will run a for loop from 0 till the current index I. Let's say I'm at a particular index I. So you're going to run a for loop from 0 till indeed I minus 1, right? And then you are going to see that if all the values in this range from 0 till I minus 1 are smaller than the current value at the ith index. I'll quickly dry run this so that it's clear at your end as well. So let's say my current index is I. So if I run from something like 0 till I minus 1, will it make sense? No, it won't. Okay, let's quickly move. By the way, right now my count value will be initially 0, but right now I see that 7 is one of these special indexes. So I say that, okay, let's increase count by 1. So I'll quickly cross this and increase this by 1. Okay, next time, where will the I go? The I will go right here, right? The I will be at the first index. Again, I'll run a for loop from 0 till I minus 1, which is 0. 0 till 0 is this number itself. Now I'll see, is this number smaller than the current number, which is 4? No, it's not, right? So can I say that this is indeed not a special index? Yes, I can say. So let's move my index I forward. So let's say my I index comes at 2. At this location, I'll say that, okay, again, run a for loop from 0 till I minus 1. In this case, I minus 1 would be 2 minus 1 is 1. So I'll consider all the values in the range 0 and 1, right? 0, 1. These are the indexes I'll consider. So 7, is 7 less than 8? Yeah, it is indeed. Is 4 less than 8? Yes, it is. So can I say 8 is a special index? Yes. So I'll increase the count by 1. I'll quickly get rid of this. And again, let's increase the index. So let's say index is at I is equivalent to 3. Again, I'm going to go from 0 till 2. So here I'll say, is 7 less than 6? No. What will I do? I'll simply stop here. I don't even need to go for these further elements. No, I won't do that. I'll say, okay, 7 less than 6? No, it is not. In this case, I'll say 6 cannot, or this third index cannot be a special index. Hence, let's move forward and continue with the process. So I'll be at 4 right now. At 4, I see the value is 11. Again, I'll go from 0 till I minus 1. So I is at 4. I minus 1. 4 minus 1 is 3. So I'll go from 0 till 3. Let's see. So in this case, I see that, okay, 7 is less than 11. Yes. 4 is less than 11. Yes. 8 is less than 11. Yes. And 6 is less than 11. Hence, can I not say that 4th is the special index? Yeah, I can say. So I can probably increase the count by 1. Great. Let's probably move forward with the next index. So I'll quickly get rid of these. Let's have the value 6. And then I'm going to go from 0 till, let's see. So I is currently at the 5th index. So again, I'm going to go from 0 till 4. So let's see, is 7 less than 10? Yes, it is. 4 less than 10? Yes, it is. 8 less than 10? Yes, it is. 6 is less than 10? Yes, it is. But is 11 less than 10? No, it is not. So can I say that 5th is the special index? No, I cannot. No, I cannot. Yes. So I'll quickly get rid of this. And then let's quickly go on to the very next problem. Not problem, but the index. So I'm at the 6th index right now. So at the 6th index, again, I'll go from the 0th index till I minus 1. In this case, I minus 1 is 5. So I'm going from 0 till 5. Yes. So 0 till 5, this is what the range of indexes I'll access. These are the prior values to this index, current index 6. So what is the current value? 15. I'll check for all the values. Is 7 less than 15? Yes. 4 less than 15? Yes. 8, 6, 11, 10, all of them are less than 15. I'll say, okay, let's increase the count value by 1 because 6th is indeed the special index. That's it. So end of the day, I'll return my count value 4. And I think so you all will be able to code this out. Assuming some of you might be a little confused, I'll write the code for this real quick. So I'll probably go here. So let's see what could be the code for this. Let's say I had a solve function, and again, I'm writing the code in Python. I can even go for something like, let's say, what do we say? A pseudocode, right? So again, the Python code is a pseudocode itself. You can convert into your favorite language, C++, Java, or C or Python, right? So again, Python is right here. So I can simply say that, okay, let's say I have the array given, and what could be the, so my count value is initially 0. I'll go in this manner. Notice carefully. For I in range, so probably some of you guys might be a little confused here. So let's quickly go over and write the pseudocode itself. So what does this look like? So let's say my return type is going to be int, right? Int solve, and my array is here, correct? And then probably you can simply say that let's say your array length is n, which is also given, so I'll probably write int n. That's great. Then I'll say int count is initially 0. So let's populate the function for int I is equivalent to 0, I is less than n, and then I'll say I plus plus. In this case, what will I do? Notice carefully. How will I determine that the current index I is a special index? So what I'll do is I'll say that, okay, go from 0 till index -1, and then I'll see that check if all the values are less than the current value. That's it. So I can kind of create a flag variable. I'll go here and then create a flag variable which is having a value 0, or let's say it's having a value, yeah, it's 0 will be fine. You can even go for a Boolean flag, true or false. In this case it's 0 or 1 in my case. So I'm going to say that, okay, check if all the values are less than the current value. So what will that look like? Flag is going to be right here. Yeah, int flag is going to be 0. Great. I'll say, okay, let's run a loop from 0 till I minus 1. So for int j is equal to 0, j is less than I, right? So I can simply write j is less than I, j plus plus. This should be j plus plus. Or I can simply say j is less than equal to I minus 1. That will also do, right? I can go for any one of them. So j is less than I kind of seems good to me. Here itself, I'll say that if the element in the array at the jth location or the jth index is by any chance it's greater than the current element, which is array of I, in that case I'll say let's set the flag value to 1 and then break out of this. So once this is done, I can simply say that, think of this, can I simply by default increase the count? Can I by default increase the count? No. Why? If my flag value remains 0 for the entire time this loop is running, I can say I can increase my count value by 1. Else, by default, if at any point of a time flag value is 1, I know there is some element prior to the current element which is greater than the current element, right? I hope that kind of makes sense. So I can simply say here that I cannot simply increase count. I can say that, okay, if flag is equivalent to 1, or let's say flag is equivalent to 0, in that case only I can say count plus plus. That's it. Again, count plus plus is simply count is equivalent to count plus 1. You can again give a read on this article that why count plus plus is much faster than count is equal to count plus 1. I hope that is very, very much clear at your end, right? Now what I'll do is, end of the day, I simply just need to return count. The reason being, I'm looking at a function which is having a return type of integer, right? Please make sure your function return type is integer. Okay, and that should be it. That should be it for the code. Now let's go over the analysis, right? Let's go over the analysis. What could be the time complexity here? So again, look at the space complexity. Am I using any external space? Am I using any auxiliary space, extra space? No, right? So the space complexity would boil down to big O of 1. We'll quickly see. Yeah, the space complexity will boil down to big O of 1. What will be the time complexity? What will be the time complexity? The time complexity in this case would be simply big O of n square, where n is nothing but the length of the array, That's pretty much it. Now, why is it n square? Because you know for a fact you are going, like, you are accessing each element, right? You are accessing each element. So in this case, I think so this is very much familiar at your end. So you're accessing each element, and for for every single element, you are looping again from 0 till I minus 1. So again, in the worst case, you are going n square times, right? Hence the time complexity being n square. Now, can we update this? I mean, can we kind of, what do we say, modify this or optimize this, right? Yeah, definitely we can. And let's look at the thought process and approach. And this is something you have to apply as well. Don't go for straight away, don't go about thinking the most optimal way, right? Again, when I'm saying that think about the brute force, I'm not telling you to write the brute force. Definitely write it in a piece of paper so that it's in front of you, but try to optimize from that brute force solution. So I'll give you the logic for optimal solution. 7, 4, 8, 6, 11, right? So that's 7, 4, 8, 6, 11, and then I guess 10 followed by 15. Now think of one thing here. Think of one thing. When I'm seeing that this index 0, 1, 2, 3, 4, 5, 6, when this index, fourth index, is special index, what am I actually seeing? I'm seeing that the value here 11 is greater than all of its previous values, right? All of its previous values. Yes, that's something I'm seeing. All of its previous values, 11 is greater. So can you think of a pattern here? What can I get it? What can I get here? What can I infer out of this? Can I not boil this down real quick? Think about this. Think about this. Let's say you have a value, current value is 100, and then you have a lot of values here. Let's say the values could be 3, 5, 65, 55, and then 101, right? That's it. These are the few values, and there could be many, like let's say 33, 21, right? There could be a lot of values. Think about this. Let's say, how do I compute that this 100 is the largest among all of this, right? I mean, it's the value 100 is greater than all of its prior values. So these are nothing but its prior values, right? The very easiest way to think about this is from the set of prior values, get the maximum element. Yes, get the maximum element. So in this case, if you get the maximum element, that would be 101, right? So is 100, now compare this maximum element from the prior element set with the current element 100. Is this 100 current value greater than this 101? No, right? So I can say that this is not indeed a special index. Now think about this, apply the same thing up here. Think about this. You are at 11, right? You are at 11. Take the maximum value out of its prior elements. What's the maximum value out of 7, 4, 8, and 6? It's 8 itself, right? So how do you say that, okay, is 11 the special index or not? Is 4 the special index or not? You simply say that, okay, since 8 is the maximum out of all the prior values, I know 11 is by default a special index. Because if I check that if 11 is greater than the maximum value towards the left of it, I know that there could be a lot of elements. There could be elements 1, 2, 3, 4, 4, and then a lot of 8s and then so on. But I know if I am greater than the maximum value towards the left of me or prior to me, I am greater than the rest of them. That's it. This is what the concept would be. Let's quickly try run the code for this, or let's quickly try to understand this, and then we'll try to code this out. So what I'll do is, for this purpose, I'll say, let me quickly get rid of that. So 0, 1, 2, 3, 4, 5, 6. For this purpose, I need to maintain few of the variables. The very first one is very obvious, count is equivalent to 0. I'll maintain something like a max value so far, right? Or I can even say prior max value, right? Prior max value will make a lot of sense. So I can simply say prior max value. Now imagine you have not even started the process. You are at 7, right? You are at literally 7. You have not even started the process. What will you do? What will you set your prior max value? Will you set it to 7, or will you set it to 100 or any random value? No, you will set it to a very simple value. Let's say a negative infinity, right? A negative infinity will do fine. Or let's say in the question it's given that there are no negative elements in the array. If this is the array A, then there are no negative elements in the array. Then you can say that the prior max value is initially -1. That's it, safer side. Now you are at the current element 7. You will say if my current element or value, right? If my current element or value is greater than my prior max value, in that case, what can you say? You can say that this index is indeed your special index, and in that case, you can indeed increase your count value. In that case, I'll say count, hey, I'll increase you. Hey, I'll increase you. That's pretty much it. Now think about this. We'll apply this formula for every single one. And again, when we go forward, we'll update the prior max value as well. Please keep in mind to update the prior max value. Okay, let's quickly go forward. I'll quickly change the color here. Let's change it to blue, or let's get it to red. Yeah, done. So currently you are at 7, right? Is 7 greater than the prior max value, which is -1? It is. So what you'll do is you'll increase the count value. Great. Now you are at which index? You are at first index. You are at 4. Again, before going to 4, what you're doing is you are updating the prior max value. So is 7 current element greater than -1? It is. So let's update. So next I'm at first index. Current value is 4. Is 4 greater than prior max value? In this case, what is the prior max value? It is 7. Is 4 greater than 7? No, it is not. Again, update the prior max value. Is 4 greater than 7? No, it is not. So let's move forward. I'm at 8. Again, is current value 8 greater than the prior max value 7? Yes, it is indeed. So what I'll do, I'll increase count. Let's increase the count value. Again, update the prior max value. Is 8 greater than 7? Yes, it is. So I'll get this down to 8. Great. Now I'm at the third index. At the third index, I'll say, is the current value 6 greater than the prior max value, which is 8? I see, no, that's not the case. Think of this now, just to see that the current index is special index or not. I don't need to go to all of these indexes. I am just maintaining this single thing, which is prior max value. Is 6 greater than 8? No, it is not. So what I'll do, I'll move forward. Again, I'm at 11, right? At 11, what's the prior max value? It is 8 from this variable. And again, if you look at the diagram, you see that the 8 is the maximum value prior to 11, right? Or prior to the index 4. So in this case, what will you do? You will say that, okay, let's increase the count value and also update the prior max value to 11, because right now I'm at the fifth index, which is having the value 10. Again, when you are at 10, you will see that, okay, is 10 greater than my prior max value? In this case, it's 11. Is 10 greater than 11? No, it is not. Simply move forward. Now you are at 15. Again, you will say, is 15 greater than my prior max value? In this case, it's 11. Yes, it is indeed greater than my prior max value. So what will I do? I'll increase the count value and also update prior max value to 15. Now my index goes out of bound. I'll stop the process. And I think so you are able to figure out that my count is storing the correct answer. In this case, it's 4. That's it. This is how we will be able to compute, right? And again, after looking at the code, we'll try to figure out the time and the space complexity. So let's see the optimized code for this. I'll quickly go over the same thing and I'll copy this same snippet. And here I'm going to write the optimized code. So end of the day, I have to return count, array is there. So let's quickly remove all of these. Yeah, that should do fine. Yeah. So you have to maintain count. Then you have to maintain something like a max, or you can simply say prior. That's a spelling mistake. So that's going to be prior max value, or you can simply go for maximum value. I'm just writing prior max value, which is going to be -1. Again, I'm assuming the elements of the array are positive, right? Are positive. Makes sense. Or I can say assuming the elements of the array, not element of the array, are positive. Okay. Now when I'm at the current index, I'll simply check if my current value, which is the element in the array at the ith index, is greater than my prior max value. Yes, my prior max value. Look how this easy is, right? In that case, I'll increase my count. That's it. And also, since it was greater than my prior max value, I'll also say that, okay, let's update the prior max value as current element, which is array of I. And I think so this should probably wrap up for our code, right? And again, you can try to dry run this for several examples. And if you face any doubt, you can definitely feel free to try to comment on this video, right? And also don't forget to subscribe to the channel as well for you to not miss out on weekly updates and videos we put out regularly, right? Great. Now, what's the time complexity you can figure out from this? I think so the space complexity is quite simple enough. It's big O of 1 because I'm not using any external space. I'm not doing anything with respect to the space part. But if you look at the time complexity, it's simple for loop, right? That's going to be a big O of n. So I can probably say that, okay, my space complexity is going to be simply a big O of 1. The reason being I'm not involving any external space, auxiliary space, right? But what about the time complexity? Currently, the time complexity is big O of n, where n is the length of the array. Yes, length of the array. So have I not reduced down from big O of n square to a big O of n? I think so. Yes, I have done this. So this is how you should be approaching a problem. Don't go about thinking about, okay, I need to optimize this and I'll do it in a big O of n time or big O of n log n 1. No, think about the brute force. Then from the brute force, try to think about all the possibilities you can do. Try to optimize from the brute force. And I'm not telling you to write the brute force on the laptop or on your editor, but write it on a piece of paper. And if you feel free to, you can definitely write it on the editor. So from the paper code, right, try to understand what could be the optimal solution, then go about writing it. Try to run for a few examples. Try to see if you are missing any edge cases, and then so on. And then you will be good to go. On that note, let's quickly go on to the next question. Meanwhile, I'll quickly go into the live and see if there's anything for me. Live and see if there's any. Yeah, Sivat Mika Chavli. Yeah, sorry if I pronounce your name incorrectly, but yeah, this question was asked in NQT. Similar question. I think so. It's a similar question. I mean, it's the same question, but I've changed the problem statement here. Yeah, I've changed the problem statement here. This was asked in the NQT, definitely. Again, if you feel like you are not able to recall any one of these things during the live session, you can definitely post your doubts in the comments and I'll try to answer them as quickly as possible. Okay. Okay. Cool. So let's go on to the let's hop on to the very next question. In this case, it's the question number 2. So it's said that okay, it's you're given an array and the array elements are this. So you can probably have both positive and negative numbers as well. You can probably see that, right? Then it's saying that okay, find the triplet with the maximum product. What do we mean by triplet? Can you think about it? What do we mean by triplet? There's a reason I've not written the answer so that I can explain probably, right? Now, triplet means any 3 numbers in the array, right? Triplet means any 3 numbers in the array in any order, right? So there's no restriction on the order part as well. So you can pick any 3 numbers. Let's say 1, minus 100, minus 40, 1, 20, 10. You can pick, let's say, minus 100, minus 47. So any 3 numbers you have to take, and then you have to product them, right? You have to, like, not product them, but you have to multiply them. That's not the right term, product them. But you have to multiply them. And then you have to see that, okay, what's the maximum product I can get out of all the combination of triplets, out of all the 3 number combinations? What's the maximum product? So what could be the brute force method here? What could be the brute force method? Let's see. So if I'm given the array, right? If I'm given the array, the brute force method, would be to probably generate all triplets. You have to generate all triplets, which is nothing but a 3-number combination from the array, and then try to see the maximum product you get, right? Try to think about the maximum product you can get out of all the combinations, right? But again, in this case, what if the array's length is 10 to the power 5? That's one short zero of a million. So let's say what if the array length is 10 to the power 6? In that case, what's the problem here? What's the problem? If the array's length is 10 to the power 6 and you have to generate all possible 3 number combinations, right, then in that case the time complexity will be quite high. Yeah, try to give me in the live chat or later on when the video gets, so try to put it in the comment what could be the time complexity for this. If the length of the array n is 10 to the power 6 and I'm looking at generating 3 like all the triplets out of the array, all possible combinations, then what's the time complexity? Try to think about it and try it in the live chat or the comment section, right? But in this case, again, yeah, I think so. This will give me TLE, which is time limit exceeded. So what can I do? I can go for a much better solution. I can run 3 for loops, right? I can run 3 for loops. In the very first for loop, I'll maintain a number which is number 1. In the second for loop, I'll maintain a number which is number 2. And in the third for loop, I'll maintain a number which is number 3. Once I have all of these numbers accumulated, I will say my maximum product I'll find out by taking the maximum of my previous maximum product and something like num1 multiplied by num2 multiplied by num3. I hope this is very, very much clear, right? So in this case, this is going to work completely fine. So let's try to look at the code for this. This is a very, very simple solution. By the way, what will be the answer here? I'll quickly write down the answer, but I won't explain right now. It's for you to figure out. Then I'll explain in the optimal solution. So again, the answer can be, let's say, okay, let's go ahead with it. The answer can be simply, let's say you pick a 20, 10, and 7, right? That would be 200. That should be 1400 if I'm not mistaken, right? 7 to 140. Yeah, 140 into 10 is 1400. So if you multiply and pick three numbers, 20, 10, and 7, you get 1400. And again, it's not mandatory that 10 is going to be always here. The 10 could be here as well. So you have to pick again three numbers, which is going to be simply 10, 20, and 7, which multiplies down to 1400. So what's the brute force solution? As I was mentioning, the first one was to generate all possible triplets, but again, I'm not going to go with that one. Let's go for the better brute force, right, which is a little optimized version of that. So let's say my function is going to be int and int solve. My array will be there, so that's int array followed by int n. And again, this is a very interesting problem. So what I can do is I can simply say that, okay, int product is initially, let's say it's 0, right? Initially product is 0. Then in this case, I can probably say that for int I is equal to 0, I is less than n, and then followed by I plus plus. That's my first number, right? This is my first number. This is the loop which gives me the first number. So I can say int number 1, or I can simply say int number 1 is going to be array of I. How do I get the second number? From where will I run the loop? I'll run from int j is equivalent to I plus 1, right? Not from I or not from 0, not from I. I should run it from I plus 1 and j is less than. So this should be j is less than n followed by j plus plus. So here I'll get my number 2. That's pretty sweet, right? So that should be array of j. Now how will I get the third number? That should be int of we can go for k, I, j, k. So where will k start from? Can we put it in the live chat if you are able to figure out? Think for me. Okay, I'll go ahead with it. So k is going to be starting from j plus 1, not I plus 1, right? And then again, k is less than n followed by probably k plus plus. So this gives me number 3, which is array of k. Now here itself, I'll say, what's my current product? What's my current product? It's simply number 1 multiplied by number 2. I'll give few spaces here. Multiplied by number 3. That's it. Now I can simply say if my current product, so I can simply say current product. So I can simply say here, if my current product is greater than the overall product, which is my answer. In this case, I'll update my product. So that should be product is equivalent to current product. And that should be it. At the end of the 3 for loops, you will return nothing but your product value. And that kind of makes sense just because product is going to be some sort of an integer value. Hence, the function has also a return type of integer, which is int. Now, what's the space complexity for this? Can you think of a place here in this code from the line 64 till, let's say, the line 79? Where have I used, where I have used extra space? No, I have not used any extra space. So I can happily say the space complexity is nonetheless big O of 1. What about the time complexity? The time complexity, the easiest way is, for how long the first for loop is going to run? It's going to run for n times. For how long is the second for loop going to run? It's going to run for n times. For how long is the third for loop going to run? Close to n times, right? Approximately close to n times. So how do we compute the time complexity when it's looping? So I know if there is a loop inside of a nested loop, we multiply, right? We multiply definitely. So that's going to be n multiplied by n multiplied by n. That boils down the time complexity part to be big O of n cube. So this is kind of better than the brute force method, right? Brute force was generating all the possible 3 combinations, but big O of n cube is quite better than this. And again, this is going to run completely fine, but for smaller test cases up till, let's say, 100, right? 100. So 100 cube would be what? It would be 10 to the power 6. But what about 1000? So 1000 cube will be, which is 10 to the power 3 cube would be 10 to the power 9, which will not pass under 1 second. So that will be problem. So how to boil this big O of n cube down to a better time complexity? Think about this. you need the maximum product, right? Maximum product. Whenever you think of max, we think of bigger numbers, right? We think of a bigger value. So let's quickly get this array down. So that's 1 minus 100. So I'll quickly write this down here. That's 1 minus 100 followed by 10 minus 40. Then we have 20 and then 7. Correct? Yeah, that's absolutely correct. Now, when you think of getting the maximum product, so you know for a fact that if you have a positive value, which is a very big value, and if you multiply that with a positive value, which is again a big value, and again you multiply that with a positive value, which is again a big value, you'll get a very big positive product, right? I think so. This is very much clear, right? Product, right? So product, if I want the maximum, I'll add bigger numbers together until I form the product. In this case, 3 number products, the first number, second number, third number. So the very first thing which might come to your mind is, let's sort this array. So if I sort this, this will give me minus 100, minus 40, or we can say negative 100, negative 40, followed by 1, 10, or this should be 1, 7, 10, and 20. Now, you might be like, okay, I'm quite smart enough. I'll probably pick the very last 3 numbers. Yes, I'll probably pick the very last 3 numbers. In this case, it's 7, 10, 20, because it's sorted. And when it's sorted, I know in the last, I'll get the very largest values, right? So I'll try to pick as large as possible and large 3 values. So in this case, it's going to be 7 into 10 into 20. Turns out that this gives you the answer 1400, which is our current answer. Yeah, that's absolutely fine. But there is an edge case to this. There's definitely an edge case to this. What if I take the input as follows? What if I take the input as follows? Let's say the input is minus 20, or let's write it in black. So let's say the input is negative 20, then it's negative 10, followed by 3, and then let's say 10, right? Now, in this case, I have already sorted the array. So the array might be given to you as minus 10, 3, 10, and minus 20. This is the array given to you. Then you sort it. So when you sort it, that you get the array as such. Now, again, by default, by your nature, you will say that, okay, I'll pick the very last 3 numbers because they'll be at max, like they'll be giving me the maximum product, right? So if you do a product of the last 3 numbers, you'll get negative 10 multiplied by 3 multiplied by 10, which is nothing but negative 300. So you get negative 300. Can you get a better answer than this? Can you get a better answer than this? Let's see what could be the better answer. Like what could be a better answer apart from this? So in this case, you can probably say that, okay, what if I try this? I pick, notice carefully, I will pick 3. Okay, I'll probably pick the very last number, which is 10. And then I'll pick the very first 2 numbers, which is minus 20 and minus 10. Now try to do the product of this. So that's going to be minus 20 multiplied by minus 10 multiplied by this value 10. Now we often tend to forget that when we are multiplying, when we multiply 2 negative integers, that is going to give me a big positive integer, right? Definitely it's going to give me a positive integer. So don't forget about it. So I can say that this is going to give me negative 20 into negative 10 is 200, 200 into 10 is 2000. So which is bigger? Is 2000 bigger than negative 300? Yes, it is. So our first thinking that, okay, I'll sort the array and take the very last 3 values. As I was doing in this case, I was taking the very last 3 values, not here, but if I sort it, I'll get the last 3 values, which was 7, 10, and 20. And I simply product them. No, I'll be a little smarter enough. I'll say that, okay, give me just 1 second. Okay, I kind of messed up on the very first one. I'll tell you, okay. So I'll say that, okay, I'll try all of these combinations. So let's say I sort the array. So few of the combinations I'll try is, I'll pick the element in the array at the last index, multiply it with the element in the array at the second last index, and multiply it with the element in the array at the third last index. So this is one possibility. Second possibility is that I'll pick the very first element, multiply it with the second element, and then multiply that with the very last element. And this is done to handle that negative multiplied by negative multiplied by a positive value. That might give me negative is positive, positive multiplied by positive is a very big positive number. So yes, I can definitely get this. Now, can you think of a mistake I have done here? So think about this. I was saying answer is 1400 because I picked 10, 20 and 7, right? But what if I sort the array? I'll get something like this, right? If I sort the array, I'll get negative 100, negative 40, 1, 7, 10 and 20, correct? So I picked the very first three numbers and told the answer as 1400. No, that's not correct. What if you pick negative 100, negative 40 and then 20? So that will be what? Negative 100 multiplied by negative 40 multiplied by 20. So this is going to give me simply 4000 multiplied by 20 will give me 80,000. Yes, so 80,000 will be the answer here. 80,000 should be the answer here, should be the answer, right? What if I had no negative element here, right? I mean, I only had negative 100. In that case, the answer would have been 1400 itself. So let's keep the answer as this. So I hope this is very much clear at your end why we are trying these two combinations, right? Why are we trying these two combinations? Firstly, you have to sort the array. So sorting will take you an n log n factor, right? N log n time complexity. And then simply multiply the very last three elements in the array. That's element in the array at n-1 at location, n-2 and n-3 at location. And take the second possibility as take the very first two elements in the array and then multiply it with the very last element in the array. That might also be one of the candidates. And that should be it. You have to take the maximum of the first possibility and the second possibility, and you have to tell that, okay, that's the answer. So let's quickly go over it and try to write the code for that. So I'll quickly copy this same snippet and I'll write the very brute force, or not the brute force, but this is optimized, right? This is much more optimized. So I'll get rid of this. Now think about this. I have the product as 0 here. Now I can simply say that, okay, let's sort the array. But again, I can sort the array using something like array dot sort and array dot sort or some functionality like that, right? So let's say I sort the array. Once that's done, that's going to take a time complexity of n multiplied by log n, right? Now I'll simply loop. I don't even need to loop, by the way. I don't even need to loop. I'll simply say, what's my first possibility? I can simply say my first possibility is going to be the multiplication of the very last three numbers in the array because it's sorted. So I'll say array of n-1 multiplied by element in the array at n-2 at location or index, and then here itself I can say multiplied by element in the array at n-3, right? n-3 third index. This is the first possibility. What's my second possibility? What if I take the very first two values in the array? That's going to be array of 0 multiplied by array of 1 multiplied by the element in the array at the very last index, which is n-1. That's it. Now how will you get the answer? You'll just take the maximum of this. So you can simply say, even you don't need the product here. So let's get rid of product. So I'll simply say that, okay, if my first possibility is greater than my second possibility, in that case, what do I need to return? I just simply need to return the first possibility because it's greatest, right? So I simply say return first possibility. So I'll quickly get rid of this, yeah, and paste this. But what if it's not the case? What if it's not the case? In that case, I'll return nothing but my second possibility. So I'll simply say return second possibility, and that should wrap up for your code. Think about this. What is the time complexity here? Okay, what is the space complexity? The space complexity here will be again a big of 1 because I'm not utilizing any external or auxiliary space, right? There's no recursion involved as well. I'm not even creating any additional data structure. So space complexity by default is big of 1. What's the time complexity? So you might be thinking that, okay, let's say I did not write this. So you might be thinking, okay, I'm saying the first possibility is this, second possibility is this, and then so on. So it's bigger of 1 because I'm not even looping. No, don't forget about the, one second. Don't forget about the sorting part, right? Since the sorting algorithm, an optimal sorting algorithm, I'm not saying a worst case sorting algorithm. A worst case could be bubble sort, selection sort, insertion sort, and then so on, right? So they kind of go to a big of n square time complexity while sorting. But in this case, you know for a fact, you're going for an optimal sorting algorithm. Hence, the time complexity by default will be at least n log n, big O of n log n. I can simply say that this is big O of n log n, and that's it. I hope so this was pretty much clear at your end. And again, as I've encouraged you not to simply think about this solution, firstly, think about the brute force solution, then try to optimize it. There's one small task at your end. Try to solve this in a big O of n time. Yes, that's possible. You have to solve this in a big O of n time. And that's going to be, what do we say, a small homework or a small assignment or a small task at your end. That's a little bit of challenge. So try to do it. It will be fun, believe me. So I think so that should be it for the session. So I'll quickly go over and see if there's any thing at my end to clarify. Yep, there's nothing as such. So yeah, I'll quickly, yeah, I should think so. I think so. I should end the session right now. But again, if you face any doubt, you have any queries, if you have any questions, you can definitely post it in the comments. Feel free to post it in the comments. And again, make sure to subscribe to the channel for latest updates on not only TCS, but various other companies as well. So yeah, thank you and subscribe to the channel. And I hope you were able to derive something from this. Yeah, thank you.